This question says, find the domain of the function f of x equals negative 6x plus 6. This function doesn't have any variables in the denominator, no variables underneath a radical, and it follows the pattern of a polynomial function where our variables are raised to whole number powers. So this is a polynomial function, and more specifically, it's a linear function. Functions of this form don't have any restrictions on the variable. So this function will have a domain of all real numbers, which we write in interval notation as negative infinity to infinity. This question says, find the domain of the function g of x equals x plus 8 over x squared minus 25. This function has a variable in the denominator, and so we'll categorize this as a rational function. Now, the significance of having a variable in the denominator is that with fractions, dividing by 0 is something that is undefined. So if you have a number divided by 0, that is undefined. So if we have a variable in the denominator, we have the possibility of this situation occurring. So we want to find the restrictions on the variable by setting the denominator equal to 0 and solve. So this is x squared minus 25 equals 0. I can factor x squared minus 25 into x plus 5, x minus 5, and then use the zero product property and set each factor equal to 0. That gives me x equals negative 5 and x equals positive 5. These are the restrictions on the domain. So first I'll draw a visual with the number line. We would mark negative 5 and 5 on the number line with open circles. Open circle means that those values are not included, and we're going to shade the rest of the line because every other real number would be included in the domain. Then I'm going to use this number line to write the interval notation. So I want to represent this interval on the left. That interval would start at negative infinity and go until the restricted value of negative 5. We're going to use parentheses to say that negative 5 is not included. Then we want to represent the interval in the middle. That interval in the middle starts at negative 5 and ends at the other restricted value of 5. Once again, using parentheses to indicate that negative 5 and 5 are not included in the domain. And then we want to represent the last interval. The last interval starts at 5 and goes to infinity. And we'll union these together. So the domain of g of x is negative infinity to negative 5, union with negative 5 to 5, union with 5 to infinity. This question says, find the domain of the function f of x equals square root of 2x minus 6. Because this function has a variable underneath a radical symbol, we're going to call this a radical or root function. And with radical and root functions, you do have restrictions whenever your root is an even root. So when you have an even root, like the square root, if you take the square root of a negative number, you get I. So we want to find values that are going to be defined as real numbers, not defined as complex numbers like I. So we have some restrictions on this variable. To figure out what those restrictions are, we want what's underneath the radical to be greater than or equal to 0. So I'm saying that the restrictions are that we don't want negative values. So I chose greater than or equal to 0 because greater than 0 is positive and equal to 0 is 0, which is non-negative. So greater than 0 and equal to 0 are non-negative. And then we're going to solve that inequality by adding 6 to both sides. That gives me 2x greater than or equal to 6. Divide by 2, and x is greater than or equal to 3. If we were to represent this on a number line, we would mark 3 on the number line with a filled-in circle, indicating that 3 is part of the domain. And our inequality says x is greater than or equal to 3. Numbers that are greater than 3 are to the right of 3, so I'm shading to the right. And then we'll use this graph to write the interval notation. And the interval notation starts at that value of 3 and goes to infinity. We're going to use a bracket on 3 to indicate that 3 is included in the domain, and a parenthesis on infinity. Infinity is a concept that the numbers continue on forever. It's not a number itself, and so we never use a bracket on infinity. So the domain of f of x equals square root 2x minus 6 is 3 to infinity with 3 included. This question says, find the domain of the function h of x equals natural log of x minus 8. So because we have a variable inside a natural log, we have a natural log function, or a logarithmic function. And there are restrictions on logarithmic functions. The log of a negative value is undefined, and the log of 0 is also undefined. And so we only can take the log of positive values. So if we want to find the domain of a log function, we take what's inside the log and we set that greater than 0. Greater than 0 are the only allowed values inside a log. Those are positive values. So log of positive values are defined. So that's why we set what's inside the log greater than 0, which are positive numbers. So then we solve that inequality by adding 8 to both sides. And we get x is greater than 8. So on our number line, we would mark 8 with an open circle to indicate that 8 is not included in the domain. Our inequality is x is greater than 8. So we're going to shade the values to the right of 8 because those are the values that are greater than 8. In interval notation, we start at 8 and go all the way to infinity. We would use a parenthesis on 8 to indicate that 8 is not included, and a parenthesis on infinity. So the domain of h of x, which is natural log of x minus 8, is 8 to infinity, where 8 is not included. This question says find the difference quotient of f, that is, find f of x plus h minus f of x over h. So this is the difference quotient for h not equal to 0 for the following function. And our function is f of x equals negative 3x plus 3. So we want to find the difference quotient, and we're going to find the difference quotient in 3 steps. I'll start off by finding f of x plus h, and f of x plus h, everywhere I see an x, I'm going to change that x to x plus h. So that's negative 3 times x plus h plus 3. And if I simplify using the distributive property, I'll get negative 3x minus 3h plus 3. Now in my second step, I'm going to calculate the whole numerator, which is f of x plus h minus f of x. Now I've already calculated f of x plus h, so I'm going to use my work from above and just copy that down. Negative 3x minus 3h plus 3. And then I want to continue by subtracting f of x. That's minus negative 3x plus 3. And notice I put parentheses around that f of x because I want to subtract all of f of x. So I need the parentheses around f of x to make sure that subtraction sign gets applied to the whole function and not just the first term. So I'm going to use the distributive property and distribute that negative. So negative 3x minus 3h plus 3 plus 3x minus 3. I have some like terms, so I'm able to cancel out negative 3x and positive 3x, a plus 3 and minus 3, and that leaves me with a negative 3h. Then in my final step, I'll calculate the whole difference quotient, which is f of x plus h minus f of x over h. Since I've already calculated the whole numerator in step 2, I'm able to just copy down the work that I've done previously, and I'm going to divide by h. The h cancels, leaving me with negative 3. So the difference quotient for f of x equals negative 3x plus 3 is negative 3.